Hi viewers, in the previous session we have discussed regarding the cyclic compounds and their nomenclature, and this session we are going to learn regarding the formation of compounds by the concept of hybridization. While then, this is Santhosh Kumar. Welcome to my channel Sims Academy. Actually, the concept of hybridization has been explained by Linus Pauling. How did he explain the concept of hybridization? Let us go into depth. Carbon is such a versatile element, that means its atomic number is 6 and its electronic configuration in terms of numbers, we write it as 2, 4, 2 electrons in the first shell. If we write in detail, 1s2, 2s2 and 2p2, it has got, removing the first shell, 2 electrons in 2s orbital and other 2 electrons in 2py and 2px and 2py orbitals respectively. This electronic configuration of carbon is said to be in ground state. We say it as ground state configuration. Now, whenever some sort of energy is given to the carbon, one element from this s subshell to s subshell jumps into the 2pz orbital of carbon atom. Whenever energy is given, these electrons, these are dirty fellows, they don't stay at one place. They always jump from here or there. One of these electrons from 2s orbital jumps from this orbital to 2pz orbital, and we mention that electronic configuration as this is one electron, we have 2s, only one electron, here 2px, 2py and 2pz, 1, 2, 3. That means this electronic configuration we write it as 2s1, 2px1, 2py1, 2pz1. This is the electronic configuration of carbon in excited state. Okay, in excited state, the electronic configuration of carbon is 1s2. Okay, it is there in the first orbit, and in the second orbit we have the configuration is 2s1, 2px1, 2py1, 2pz1. In ground state, the electronic configuration of carbon is 1s2 in the first orbit and 2s2, 2px1, 2py1, and there are no electrons. Even there is no single electron in the 2pz orbital of the carbon atom where it is in the ground state. Now coming to the excited state, that electron from 2s orbital gets excited and jumps into the 2pz orbital. Hence, the electronic configuration of carbon in excited state, we write it as 1s2, okay, first orbit, 2s1, 2px1, 2py1 and 2pz1. This is the excited state electronic configuration of carbon atom. Now, let us move back to the above principle. What did he say? According to above principle, electrons always enter into the orbitals having the least energy first. The energy of an orbital is given by its m plus l value. M plus L value, S, P, D, F. L values we have 0, 1, 2, 3. Now we have written the excited state electronic configuration of carbon is 1s2 in the first orbit, 2s1, 2px1, 2py1 and 2pz1 in the excited state we mentioned. Okay, I will write like this. This is 2s orbital. These are 2p orbitals. 1, 2, 3. This is 2px, 2py and 2pz. Why did I mention 2s orbital down and 2p orbitals, the 3 2px, 2py and 2pz orbitals upwards? I'll let you know. And one more important thing is that these 2px, 2py and 2pz, these three orbitals are called as degenerated orbitals. Emantamu degenerated orbitals. Degenerated orbitals in the sense these orbitals have got same energy in the absence of magnetic field. The orbitals which possess same energy in the absence of magnetic field are called as degenerate orbitals. Hence, these three orbitals 2px, 2py and 2pz, these three do possess the same energy, hence these are called as degenerate orbitals. And according to Hund's rule of maximum multiplicity, we have got its electronic configuration. Pairing of electrons takes place after all the degenerate orbitals are filled with single electron first. Yes, hence one electron from here jumped into 2pz orbital and this is the excited state. And now coming to 2px, 2py and 2pz orbitals, as we discussed just now, these three orbitals do have the same energy. Then what about 2s? N plus L value, let us write for 2s, N value is 2 and for S sub shell L value is 0, it is 2. For 2p, 2 plus P sub shell L value is 1, that is 3. Okay, 2px, 2py, 2pz. That means N plus L value of Bohr principle, according to Bohr principle, 2s orbital has got lower energy compared to 2p orbitals. Now, during the formation of methane molecule, which molecule? Methane molecule. Carbon, its electronic configuration in the excited state, it is 1s2, 2s1, 2px1, 2py1, 2pz1. Now, this carbon has got 4 half-filled orbitals, that means 2s, 2px, 2py and 2pz orbitals. Now, there are 4 hydrogens. 4 hydrogens. All these are 4 hydrogens are of similar type. Then, one to be bonded with 2s, other 3 should be bonded with 2p orbitals. Is it correct? How come one hydrogen moves to the lower energy? Why should it get bonded with 2s orbital? That means when we have unequal sharing of energies or unequal sharing of orbitals, this is not correct because 4 are similar atoms, 4 are hydrogens. That means, I'll give you a beautiful example. We have got 4 guests. Initially, we have only 3 guests. Suppose our mom keeps some tea. Okay, we have filled 3 cups with 3 cups filled with tea. Unknowingly, the 4th guest has come. 4th guest has come. That means he is also a guest for us. Now we need to offer him the tea compulsorily along with these 3 guests. Then what do? We just pour the tea from the remaining cups into the 4th cup. That means we rearrange or reshuffle them such that all the cups contain the same quantity of tea. Am I right? Even this happens in our houses. Whenever guest comes, we also ask for cool drink or something else. Generally, we ask our dirty little kids. They always look at cool drinks only. Yes, this happens. That means whenever we have unequal sharing, we rearrange. That means we pour here and there and we maintain the same quantity in all the 4 cups. In the similar scenario, we can think over here 4 are hydrogen atoms only. Then if this carbon wants to get bonded with 4 carbon atoms where 2s orbital has got lower energy compared to 2px, 2py and 2pz orbitals, these carbon atom, now these orbitals of carbon atom, they undergo intermixing. What do they undergo? They undergo intermixing. Intermixing of 1s and 3 orbitals takes place. Here, observe carefully, 2s orbital has got lower energy compared to 2px, 2py and 2pz orbitals. But after intermixing of these 4 orbitals, 1 2s and 3 2p orbitals, we get new orbitals having equal energy. And those new orbitals having equal energy, 2s, 2px, 2py, 2pz, those orbitals we call them as sp3 orbitals. Because why do we say sp3? Because here 1s orbital and 3p orbitals are involved in the process of intermixing. And here how many orbitals are formed? 4 orbitals are formed. How many orbitals have been involved before? 4 orbitals have been involved before. How many orbitals are formed? 4 orbitals. That means how many orbitals are present before intermixing? The same number of orbitals have been formed after intermixing. In the sense, this process of intermixing of orbitals which have different energies. 2s is having somewhat different energy compared to these 2pz orbitals. The process of intermixing of pure atomic orbitals having different energies to give rise to the equal number of orbitals having same energy. Here the orbitals so formed after hybridization are called as sp3 orbitals, and these orbitals are called as sp3 hybrid orbitals. These sp3 hybrid orbitals, 4 orbitals have same energy. Hence, these 4 orbitals of sp3 orbitals of carbon atom, they intermix, they overlap with 1s1 orbital of hydrogen atom, resulting in the formation of 4 sigma bonds in case of methane molecule. I hope you understood the concept of hybridization. Before we had orbitals with different energies. After intermixing, we got the orbitals of same energy. How many orbitals are present before intermixing? 4 orbitals. How many orbitals are present after intermixing? 4 orbitals. That means number of orbitals haven't changed here, but the distribution of energy, in the sense unequal distribution of energy is present previously. Now we have equal amount of energy for these 4 hybrid sp3 orbitals. Hence we define hybridization as the process of intermixing of pure atomic orbitals having different energies to give rise to the equal number of orbitals having the same energy is called hybridization, and the new orbitals so formed are called as hybrid orbitals. Here then 1s and 3p orbitals are hybridized. We get 4 hybridized orbitals, sp3, 1s and 3p orbitals, and hence 1s1 orbital equals sharing here, 1s1 orbital of hydrogen atom. This is the formation of methane molecule. Then how do you explain the formation of ethylene molecule? Linus Pauling, he explained the concept of hybridization in a beautiful manner. Okay, let us see. As we know, what is the atomic number of carbon again? The atomic number of carbon is 4. It is 6. The atomic number of carbon is 6 and its electronic configuration 2, 4. 1s2 in the first orbit, 2s2 and 2px1, 2py1. This is in the ground state, as I told you previously. This is ground state. Now in excited state, one electron from 2s orbital jumps into 2p orbital. That means then electronic configuration, it becomes 1s2, 2s1, 2px1, 2py1, 2pz1. Here one electron. Here we have 1 in 2px, 2py and 2pz orbitals. Now in the formation of ethylene molecule, that is C2H4, its IUPAC name is Ethyne and its common name is ethylene. Okay, in the formation of ethylene molecule, we have 2 carbon atoms and 4 hydrogen atoms. Now, Linus Pauling explained the formation of ethylene molecule like by using the concept of hybridization. How? This carbon atom undergoes here SP2 hybridization. That means 1 2s and 2 2p orbitals are being involved in the process of hybridization. As I told you, whenever how many orbitals are undergoing hybridization? 1 2s, 1 2px and 1 2py orbitals. The number of orbitals are 3. Hence, we get 3 hybrid orbitals. What are those 3 hybrid orbitals? This is one sp2, sp2, sp2. Here we have, let us say like this. These are sp2 hybrid orbitals. Now we have to observe carefully here. There is one unhybridized 2pz orbital. This is unhybridized 2pz orbital. Okay, now coming to the another carbon, the same, it also gets one sp2, another sp2, another sp2 and one unhybridized 2pz orbital. Now we can understand here sp2 hybridized orbital. How many orbitals are there? 1s, 2p. 3 sp2 hybridized orbitals are there. This is the pure orbital. This is also the pure orbital. Excluding that, in each carbon atom we have, if you can observe carefully, 1, 2, 3. 3 sp2 hybrid orbitals. Here also 1, 2, 3. 3 sp2 hybrid orbitals. Here, sp2 hybrid orbital of one carbon atom overlaps linearly end on end with sp2 hybrid orbital of another carbon atom, resulting in the formation of a sigma bond. Okay, one bond is formed between 2 carbon atoms. Now, how many hydrogens? 4 hydrogens. 4 hydrogens. This is 1, 2, 3, 4. 1 s1 orbital of hydrogen atom. Here 1 s1 of hydrogen, 1 s1 of hydrogen, 1 s1 of hydrogen. These form sigma bonds. These form sigma bonds. Got it? We have sigma bonds have been formed. Now what about this unhybridized pz orbital? This unhybridized pz orbital undergoes sidewise overlapping. We discussed previously. The end-on-end overlapping of orbitals result in the formation of a sigma bond. The sidewise overlapping of orbitals results in the formation of a pi bond. That means there forms a pi bond between 2pz and 2pz orbitals of two carbon atoms. If I take this is carbon 1, this is sp2 sigma bond, this is sp2, another hydrogen, sp2, another hydrogen, sp2, another hydrogen, sp2, another hydrogen, bond formation, and unhybridized 2pz forms. Hence, carbon-carbon in the ethylene molecule, we have a double bond. I hope you understood this. Now, let us move on to the formation of ethyne molecule. Ethyne molecule. Ethyne molecule, again the same story repeats. Carbon atomic number is 6 and its electronic configuration is 2, 4. That is 1s2 in the first orbit, 2s2, 2px1 and 2py1. Now in excited state, one electron from 2s orbital jumps into 2pz orbital. Now the electronic configuration of carbon in excited state, it becomes 2s1, 2px1, 2py1 and 2pz1. Here this is s orbital and here we have p orbitals, 1, 2, 3 electrons are present. This is the electronic configuration of carbon in excited state. Now, in the formation of acetylene molecule, or ethyne is the IUPAC name and acetylene is the common name here. In the formation of acetylene molecule, Linus Pauling explained as there will be the hybridization of only one s and one p orbital. Only one s and one p orbital. That is one 2s and one 2px orbital. Hence, these two orbitals, how many orbitals are undergoing hybridization? 2 orbitals. How many hybrid orbitals are formed? 2 hybrid orbitals. What is the difference between the pure orbitals and hybrid orbitals? These two pure orbitals, they do not possess the same energy. But what about the hybrid orbitals? Those two hybrid orbitals possess the same energy. Didn't understand? I'll let you. Suppose 2s has got 25 units of energy. 2p has got 75 units of energy. Remix. Then after hybridization, sp2 hybrid orbitals are formed, 1s and 1p. Then both gets 50-50 units of energy. That means while intermixing, the redistribution of energy takes place. That means the intermixing of orbitals takes place, giving rise to the equal number of new orbitals called as hybrid orbitals, and those hybrid orbitals have got the same energy. Now, in the formation of acetylene molecule, this carbon undergoes SP hybridization, resulting in the formation of 2 sp hybrid orbitals. This is one sp, this is another sp. And here also another carbon, it also undergoes sp hybridization, and here also it gets 2 sp orbitals. This is one sp and this is another sp. And we should observe carefully here, there are 2 unhybridized orbital in each carbon atom. 2 unhybridized unhybridized 2py and 2pz orbitals. Let us say this as 2py and this as 2pz. 2py, 2pz. Here also, this as 2py and this as 2pz. 2py, 2pz. Now what happens? Already carbon, 2p, 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 they formed the intermixed by means of end-on-end overlapping, resulting in the formation of a sigma bond. And here another sp, how many hydrogens are there? 2 hydrogens. One s1 orbital of hydrogen atom. Here also one s1 orbital of another hydrogen atom. Now, what about these unhybridized orbitals? Here sigma bonds are formed. Here also sigma bonds are formed. Now here 2py unhybridized orbital of one carbon atom overlaps sideways to give formation of a pi bond. 2pz orbital of one carbon atom overlaps again sideways, resulting in the formation of another pi bond. That means in between two carbon atoms, if we observe one sigma bond and two other pi bonds are formed. If I write this one, this is sp overlapping over, and other one 2py, another one 2pz. Here another sp with hydrogen, another sp with hydrogen. That means in between two carbon atoms we have a triple bond in case of this acetylene molecule. In case of methane molecule, you see methane, it is an alkane, CH4. All are single bonds. Ethyne, it is an alkene, C2H4. We have a double bond. In case of ethyne, alkyne, we have a triple bond. Yes, beautiful, right? This is the concept of hybridization. This is how we explain the formation of certain molecules like methane, ethane, ethene, ethyne. That is, ethene means ethylene and ethyne means ethyne means acetylene, C2H2. This is about the hybridization. One important thing we have to keep in our mind is that the number of orbitals before intermixing are equal to the number of orbitals after intermixing. The orbitals which are present before intermixing are called as pure orbitals. The orbitals which are formed after intermixing are called as hybrid orbitals. These pure orbitals possess different energies. The hybrid orbitals always possess the same energies. Hence we defined hybridization as a process of intermixing atomic orbitals having the same energy, giving rise to the equal number of, having different energies, giving rise to the formation of equal number of orbitals having same energy. Yes, here we got, in case of methane, sp3 hybridization, the carbon has undergone. There we got 4 hybrid orbitals. In case of ethane, it has undergone sp2 hybridization. We have 3 sp2 hybrid orbitals, one between carbon-carbon sigma bond and other between the hydrogens. Yes, for this carbon. Here also one sp2 and other sp2. And in case of ethyne, I have mentioned S and P. It undergoes sp hybridization. One S and one P orbital are involved here, giving rise to two sp hybrid orbitals. They do have the same energy. One sp of carbon and other sp of carbon, they intermix, they overlap by means of a linear overlapping takes place here. It forms sigma bond and other sp with hydrogen, other sp with hydrogen. Remaining unhybridized orbitals 2py and 2pz, what so are present, they form pi bonds by means of Okay guys, in today's session we have learned about the hybridization, the formation of methane, ethylene and ethyne molecules, and in the next session whatever we are going to learn will be intimated very soon. And thank you very much for watching the video, watching the video here, and please do subscribe to the channel and share for the needy people. And I hope this lockdown will make you safer. Stay home, stay safe, and this is Santhosh Kumar from Sims Academy signing off. Bye.